Section 6.5, Solving Applications Using Rational Equations. In this example, we'll take a look at solving a work problem which generates rational equations. In this problem, it states one pump can drain a pool in 9 minutes. When a second pump is also used, the pool only takes 6 minutes to drain. How long would it take the second pump to drain the pool if it were the only pump in use? So I have set up here a table to help us organize our information. When we're working with a work problem, no pun intended there, the correct approach is to focus on the rate of work. So we will have a column for rate and time, and to define work, we take rate times time to give us work. So we'll need a column for the amount of work that is being produced. We are talking about 2 different pumps in this problem, and to capture the information that was given, it tells us that one pump can drain a pool in 9 minutes. Rate is the amount of work done in 1 unit of time. They're doing this job of draining the pool in 9 minutes, at least the pump, this first pump is, so its per minute rate is 1/9 of the job. Every minute that goes by, it's doing 1/9 of the job. After 9 minutes, the job is done. One job is done. Then it tells us when a second pump is also used, the pool only takes 6 minutes to drain, which makes sense. 9 minutes for one pump now receiving help would be less time. That makes sense. And we'll put that information down for the time that each of these 2 pumps are working together. We have enough information that we can determine the amount of work that pump 1 is doing. If we take rate times time, 1/9 times 6 will get the amount of work. So we end up with 6 times 1/9, which is 6/9, which we can reduce since there's a common 3 in the numerator and the denominator. 6 divided by 3 is 2. 9 divided by 3 is 3. So the amount of work pump 1 is doing is 2/3. The problem continues to ask us how long would it take the second pump to drain the pool if it were the only pump in use. So what we don't know is the time for pump 2 to drain this pool, and we'll let that equal x. Similar to what we did with pump 1, it takes 9 minutes working alone. We're letting x represent the time for pump 2 working alone, so its rate, and again, keep in mind that the rate is the amount of work done in 1 unit of time, in this case minutes. So every minute that goes by, it's doing 1/x amount of work. We now can fill in the last cell in our table. Rate times time, 1/x times 6, leaves us with a 6/x for the amount of work done by pump 2. Now to come up with an equation, we will take the work from pump 1 plus the work created by or done by pump 2 and set it equal to the job done. Well, we found that the work pump 1 is doing is 2/3. The pump 2's work is 6/x, and the job done is emptying the pool. We're only emptying the pool once, so there's 1 job that's being done. We now have a rational equation that we need to solve. In previous lessons, we have found that we can make life much easier when we have an equation with fractions or rational expressions by multiplying by the least common denominator, and we have a denominator of 3 and x, so our least common denominator has to have a 3 and an x in it. To maintain equality, we'll multiply every term by 3x. Simplifying then, 3x is understood to have a denominator of 1. We have a common factor of 3 over 3, which is equivalent to 1, times x times 2 gives us a 2x from the first term. We have x's canceling out. Common factors in the numerator and the denominator is equivalent to 1, leaving us with a 3 times 6, or 18, and 3x times 1 is 3x. It looks a lot better as far as solving. We want to get the variable together, so subtracting a 2x from each side cancels out the variable on the left, leaving 18. 3x minus 2x is equal to x. And the question was asking us, how long would it take the second pump to drain the pool if it were the only pump? We let x represent the time for the second pump, so our answer would be 18 minutes for the second pump working alone. And it's always a good idea to check your answer to verify that you have solved it correctly.